One of the common ways we measure acid strength is through measuring the H+ concentration in terms of molarity. Sometimes, however, molarities have very, very small values, 10 to the negative 3 or 7 or 9 molar. And there's another method that we can use to measure the concentration called pH. pH has a simple definition. It's just the negative log of the H+ concentration. This is a useful way to measure the concentration of H+ ions because it brings the numbers into something much more close to 1, much more easy to work with values. If we use the concentrations that are given above, 1 times 10 to the minus 3, 10 to the minus 7, and 10 to the minus 9, we get the following pH values. In aqueous solutions, a neutral system has a pH of 7. Any pH smaller than 7 is acidic and will have a concentration of H+ that's larger than 10 to the minus 7. Any pH that's greater than 7 will be basic and will have an H+ concentration smaller than 10 to the minus 7 molar. pOH is a method for measuring base concentration and works in exactly the same way. Water has a property called autoionization, where liquid water can split up into H+ and OH- ions. This equilibrium has its own K expression, and notice that there is no liquid water in that K expression because liquids typically don't go into a K expression. The K value for this equilibrium is special. It's called Kw, and it has a value of 1 times 10 to the minus 14. And in any aqueous solution, whether it's acidic, basic, or neutral, water exists, and water will exist in this equilibrium. So it means that no matter how much acid or how much base you have in the system, water's equilibrium expression will be true. So if you have an acidic system, you'll have lots of H+ ions, and you'll have very few OH- ions, but their product will still equal 1 times 10 to the minus 14. And this means that in any solution, you can use the H+ ion concentration to calculate the OH- concentration and vice versa. It's also possible to write a pKw. A pKw is calculated exactly the same way that a pH or a pOH is calculated. The pKw for pure water is always 14. And if you take the negative log of our K expression, that is, if you take the negative log of both sides of that expression, you end up with the following. And this means that for any aqueous solution, you can say that the pKw is equal to the pH plus the pOH. Or you can rewrite that as 14 equals pH plus pOH.